Okay, so we have a potentiometer here. Okay, this slide wire AB is length 1 meter long. Yeah, this AB is 1 meter long and resistance is 8 ohm, used to measure the potential difference across AC. Okay, actually this is not so clear. Below there is a even more clearer picture. Yeah, this one. Yeah, yeah. So this AB is 1 meter and resistance is 8 ohm. Okay, and we have a battery here, 5 volt, and this is a resistance 12 ohm. Okay, so this is big E, and this is the resistance big R, and then also the length, the LAB is 1 meter. The resistance AB is 8 ohm. Okay, and then this is the length AC. All right. Okay, so now the question asks. Okay, here we have two resistor here. Resistor 10 ohm, 10 ohm, and then this is another battery here below. So we can label this as E2. Sorry, this one is E2, and this is small R2. Okay, and this thing is big R2. Okay, big R2. Okay, so E equal to 5 volt, yeah, R equal to 12 ohm. This is R2, and E2 R small internal resistance, R2 LAB, RAB. Okay, this this whole wire is actually a resistance wire. Okay, now the first question asks about what is the balance length L. That means he asked for the LAC. Yeah, or actually, in fact, all these questions ask for LAC. Yeah, or ask for LAC. When the switch, yeah, this one is actually S2. It's wrong here. Actually, it's S2. All these are S2. If S2 is open and S1 is closed, so how to do the first question? A, when S2 is open, S1 is open. Okay, S2 open, S1 open. So it's something like this. Okay, if S2 open and S1 is also open, that means it's something like S2 open. Sorry, just now is S2 open, S1 open. So that means both also open, like this. Yeah. So we can say these two actually, in fact, they are not there. Okay, not connected because both are open. Okay, so it becomes something like where you must redraw the diagram, so it becomes something like this. So there's no R2 here. Okay, how to do? So we can see after we redraw S2 open, S1 open, so there's no R2. The R2 is not connected, so it just have the battery E2 there. Yeah? Battery E2 and internal resistance R2. Just this one is connected. These two are not connected. So just this battery is connected. Okay, so how? First of all, above here there is current flow. And this 5 volt is E, and this 12 ohm is the big R, and then AB is the RAB. So here we can do Ohm's law. E equal to I R plus RAB. Okay, then we substitute the information. E equal to 5, R equal to 12 ohm, and RAB is equal to 8 ohm. Okay, so we can find the current. Okay, we can find the current that flows in the circuit here. Okay, which is 0.25 ampere. Alright, after that we can find the voltage AB. Voltage AB is the current that flows through multiplied by resistance AB. So current multiplied by resistance AB. Resistance AB just now, resistance AB just now is 8 ohm. I mean the whole wire is 8 ohm. So 0.25 times 8, you get 2 volt. So VAB is 2 volt. Okay, and then VAC. Okay, AC is parallel to the battery. Parallel battery, and because there's no current flow, so VAC is equal to EMF 2. Because when no current, there's no potential drop across the internal resistance. There's no potential drop across internal resistance, so R2 can be neglected. So VAC is only equal to E2. Okay, VAC equal to E2. So equal to E2. E2 is 1.5 volt. And then finally, we use the ratio formula. Yeah, LAC over LAB. LAC over LAB divided by VAC over VAB. So LAB just now is 1 meter long. The whole wire is 1 meter long, and VAC is 1.5. VAB just now is 2 volt. Substitute, we get LAC is 0.75 meter. Now the second question asks for the length AC when S2 is open, S1 is closed. Okay, S2 open, but S1 is closed. So that means how is it? S2 open. That means okay. S2 open means this one is not there, but you have resistance R2 is just now is S1 is closed. Oh, S1 is closed. That means this part is connected. Okay, this part is connected. So S2 is not there. S1 is there. So R2 is equal to 10 ohm. R2 is equal to 10 ohm. So the circuit becomes like this. Okay, so when S2 is open, S1 is closed. Okay, so that means the R2 is equal to only one of the resistor 10 ohm. Okay, only one resistor 10 ohm. So the circuit becomes like this. Okay, so yeah, becomes like this. So okay, so just now the top circuit here, the current is still the same like before, 0.25 ampere. Same like before, 0.25 ampere. Okay, 0.25 ampere. VAB is still 2 volt, same like before, VAB 2 volt, because nothing changes here. Here, nothing changes. Nothing changes, yeah. So, but here, below here now got current. Last time here below has no current, but now below here got current because it's a complete circuit. Now below here is a complete circuit, so you can do Ohm's law below. So E2 equal to current I2 just flow here, I2 times R2. R2 is the 10 ohm, and plus internal resistance R2, which is 3 ohm. Okay, 3 ohm. So E2 is 1.5 volt. So we can find the current at the circuit below, I2. Okay, so I2 is 0.115454 ampere. So this I2 and I is different. This I flows at the top circuit only. I2 flows at the bottom circuit. These two current does not mix together. Yeah, does not mix together. So after that, for this case, VAC is equal to VR2. Voltage across AC equal to voltage across R2, which is the 10 ohm. Voltage across, because they are parallel to each other. Okay, voltage across R2, 10 ohm. VAC equal to VR2. So VR2 also equal to current I2 times R2. Yeah, because I2 flow through R2. 10 ohm. So I2 just now we got already. This one just substitute here. So we can get the VR2, which is 1.154 volt, and this one also equal to VAC. And once we got the VAC, then our job is almost done. We can use the ratio to find the length AC. Length AC over length AB equal to VAC over VAB. So just substitute length AB just now 1 meter, VAB 2 volt, same as before. We get length AC equal to 0.577 meter. Okay, so the final question C, find the balance length L when the switch S2 is closed. Okay, S2 now is closed and S1 also closed, both closed. Okay, both closed means S1 is closed, S1 is closed, S2 also closed, both closed, both closed. Oh, that means now R2 is the whole thing. So there are two resistor 10 ohm in parallel. Two resistor 10 ohm in parallel. And then find the balance length AC. Yeah. So this one you need to find the equivalent resistance. So for the case S2 closed, S1 also closed. So this is the circuit. So you have two resistor 10 ohm in parallel. You need to combine them, become the equivalent resistance. When they combine in parallel, 1 over R equal to 1 over 10 plus 1 over 10. The equivalent is 5 ohm. So in the combo is 5 ohm equivalent resistance after combine. So the below circuit here become, after combine, it becomes like this. Like this. Okay. The equivalent is now is 5 ohm. Yeah. And of course this one become the new R2. This one become the new R2. So it's same as before. You have below here you have E2. 1.5 volts and resistance R2, internal resistance R2, 3 ohm. This is the internal resistance of the battery, and this is the R2, 5 ohm. Last time is 10 ohm, now this is 5 ohm. So and current I2 pass through the circuit below here. Okay, so this is the I2, and the top circuit is I. Yeah, and the top circuit is I, the bottom circuit is I2. Okay. So same like before, the top circuit never changes, so the current still 0.25 ampere, voltage AB still 2 volt. Okay. But current I2 changes because R2 changes. Last time 10 ohm, now become 5 ohm because there are two resistors in parallel. Okay. So you need to find the new current I2. New current I2. So new current I2, you also do the E2 equal to I2 R2 plus R2. So E2 is 1.5, R2 is 3 ohm. The big R2 now, the new R2 is 5 ohm. Now the I2, the new I2 is 0.1875 ampere. Okay. So after that, the VAC, the voltage AC, is equal to voltage across the external resistor R2. Yeah, VAC equal to VR2. Okay, VAC equal to VR2, and of course, VR2 is current I2 times R2. Okay, and I2 is 0.1875 substitute, and the new R2 is 5 ohm. Multiply, you get this answer. And once we get the VAC, our job is almost done. We can do the ratio LAC over LAB equal to VAC over VAB. Just substitute, and then VAB is 2 volt as usual. LAB is 1 meter. So we get finally LAC is 0.4688 meter. Okay, so that's for question C.